Question 9. So remember to answer part 1, you really need to complete the square a couple of times. So just start off by putting the 2x terms together and the 2y terms together. Now you need to complete the square with regard to x squared minus 2x, which is x minus 1 all squared minus 1. Remember we got the minus 1 from halving the coefficient of the x, and the minus 1 is to take out that third term, which you would get if you multiplied out this pair of brackets. You would get x squared minus 2x plus 1. We don't want the plus 1, so we need the minus 1. So that's instead of these two terms. We repeat this exercise for the two y terms, giving us this. Then obviously we've still got the minus 19. So gather up our minus 1, our minus 25, and our minus 19, minus 45. Add 45 to both sides, we get it in this format. The centre of the circle is therefore 1 minus 5, and the radius is the square root of 45. Now for part 2, to verify this coordinate is on the circle, simply substitute these x and y values in, and check that you do get 0, which indeed you do. Now for part 3, this takes a bit of thinking. I think the temptation is to differentiate, which is way beyond C1. So think about what we've got. We've got the centre of the circle at 1 minus 5, and the point we're given is 7 minus 2. So consider the radius from the centre to this point. What is the gradient of the radius? We're doing y step over x step. Now I'm going to do top take away bottom, so we get minus 5 minus, no I haven't, I've done bottom take away top, excuse me. So minus 2 minus minus 5 and 7 minus 1. So that's the gradient of the radius. So minus 2 minus minus 5 is add 5, so minus 2 add 5 is plus 3, 7 minus 1 is 6, 3 over 6, which is 1 over 2. Now that's the gradient of the radius. Now remember the tangent is going to be perpendicular to the gradient of the radius. That's one of the circle theory rules. So the gradient of the tangent is minus 2. So we've got the gradient of the tangent, we know the point that it goes through, 7 minus 2, so we can substitute that into the classic equation of a line formula here, tidy it up, and we get 2x plus y minus 12 equals 0.